Okay, we'll be doing AMath O-level revision already. Today is paper 1, part 1. Okay, so let's do this question of indices. This is indeed AMath paper. Actually, the syllabus, they adjust it a bit. They remove the indices from the O-level syllabus, but actually under exponential, logarithm exponential, this is still considered under exponential. So how do we know that it's considered exponential? You see that the power got x. Do you see that the power got x? Okay, when power has x, it's under exponential. Okay, so it is still tested. It is still within O-level syllabus. So let's do. Okay, this one I'm going to write out the question first. Okay, so they give me this information. Okay, and your task is to find out this value over here. So let's take a look at this one. You see 49, you see 7, 7, and 3, 4, 3. So you need to know that, oh, okay, I must change them to the same base. Okay, change them to the same base. So 49, this is perfect square, 7 to the power of 2. 3, 4, 3 is a perfect cube, which is 7 to the power of 3. So what I'm going to do is change this 49 to 7 to the power of 2. And you got to put bracket, the 2x minus 3 will be outside. Okay? And this will remain as it is because it's already base 7. This one also remain as it is. 3, 4, 3 will be 7 to the power of 3. Again, bracket, and then put your x minus 1 outside. So now, let's rainbow this one. So this is indices. So-called power rule tell us that this one is 2 multiplied the outside number. So it will be 7 rainbow. So it will be 4x minus 6. Remain the same. Remain the same. This is just rainbow. So it's 7, 3x minus 3. So now this is same base. And you divide. So that means you minus the power. Wait, what thing? Wait, what? You can try out because you see, why is it that we know that it's 7 is you look at the neighbors lah. You see base 7, you see 49 is also 7. So high chance 3, 4, 3 is base 7. So you can try out, you see. Okay, definitely not 2, right? So you try out 7, 4, 3. Even let's say you go and try out 7 to the power of 4. Then you realize, too big. Then you go and try a smaller number. Okay, there's no reason for you for them to come up with this question if it is not base 7. Okay, if it's not base 7. Even if, let's say, you forget 3, 4, 3 is a perfect, you can always use calculator to verify. Understand? Okay, so once we have that, okay, and we're going to divide. Divide means you got to minus them. Okay, so it is this rule. See here, this rule. When ax divided by ay, when it's divide same base, you minus the power. So when divide, it can also be written in a fraction form. So now currently now, this is divide. So I write it as 7, 4x minus 6 minus 3x equals to 7, 2x plus 1 minus, this one be careful because this 3x minus 3 is like a number. So when you subtract it, you must put bracket. You must put bracket. So subtract 3x minus 3. Okay, so simplify it. 4x minus 3x is x. So this is 7x minus 6. 7. See, 2x minus 3x. So this is minus x. Plus 1. Minus 3 means plus 3. So this is plus 1 plus 3. So in the end, it is plus 4. So now you have both sides single base. You can remove the base and you can say, oh, so therefore, our x minus 6 is equals to minus x plus 4. So it becomes a linear equation. Just solve this linear equation. So it will be x plus x equals to 4 plus 6. So we have 2x equals to 10 and x equals to 5. So don't stop there. So some students always have the habit, oh, I solved the equation and then I finish the question and I move on to the next. But you must remember that to always make it a habit to read back the question and see what is your final thing that you need to find. So in this case, I'm going to sub my x 5. So in the end, cube root 3, 4, 3 to power of 5. You can just press a calculator. So cube root 343 to the power of 5. Okay, and press equal. So we get 16807. So answer is 16807. And we are done. Okay. So this is how you do this so-called indices question. So in O-level, AMath, there's a chapter indices. And they expect you to know all the laws of indices when they start to do the AMath, this exponential. So let me recap some important rules that you need to know. Okay, indices rules. So when you have same base multiply, you add the power. Okay. Over here, when it's same base divide, you minus power. Just now I mentioned already. So the divide, sometimes you can write it in the fraction form. It's the same meaning. It's the same meaning. And this one is when it's power. So when it's power, it's multiply. That's why it's x times y. Do you go through AMath? I'm doing AMath now. Okay. So this is how you do this question. This is how you do this question. Okay, let's move on to the next question. Oh no, I don't do calculus. I only do O-level, Singapore Math up to O-level. Sec 1 to Sec 5. Okay. Now let's take a look at okay, before I go to this search question, before I go through the search question. Okay, this is my complete indices law. Okay, so if you can take a snapshot, you can take a snapshot. So, just now I've mentioned about this. Okay, so now look at this bottom one. This bottom one. In this question, I did not use this. Okay, but these are laws of indices that you have to know. So look at this. Okay, so you see this is multiply, but if you notice, this is different base. Just now the upper one, it is same base. Okay, same base multiply, you add the power. Look at this one. This one is different base but same power. So in this case, you rewrite it as AB to the power of X. Hello. Okay, then now, this one, different base divide, so it become A over B bracket to the power of X. So this is actually these two is a very commonly tested laws which students always forget. Okay, so take note of these two. Okay, then this one, when you have negative index, how do you handle them? Okay, so A to the power of minus 2 is like over 1. So when it is negative index at the numerator, you just need to bring it down and then it become positive. So likewise, if let's say, for example, if I have 1 over, I should use red pen. If let's say I have 1 over A to the power of minus 3, for example. So if it's negative index at the denominator, then you just need to bring it up. So it becomes A to the power of 3. Okay. Next, which is the so-called, they call it certs. They call it certs, but in AMath, it's not certs. So I'm going through this, although this is indices in AMath, but you definitely need all this concept in AMath. So A to the power of Y with the so-called X root. So you need to know that to write the fraction form, the root is the denominator. So the power is the numerator. Okay? Over here, so square root A, they did not write the 2, but you need to know that square root is actually an invisible 2 there. So it's actually A to the power of half. Cube root of A. So cube root of A is A to the power of 1/3. This is quite, this one must know. You must know square root is to the power of half. You must know cube root is to the power of 1/3. Okay, so these are the indices laws that you need to know. Okay, so now let's move on to certs. Let's move on to certs. Okay, this question, they say that a cuboid has a square base of length 3 plus square root 2 and a height of h cm. Okay, and they give us that the volume of the cuboid is blah, blah, blah. So without using calculator, okay, obtain an expression for h in the form of this. So Teacher Kangie like to draw diagram, although my drawing sucks, okay? But so a cuboid with a square base. So I will draw this, okay? So this is my cuboid with a square base, and they tell us that the square base, the length is 3 plus square root 2. So these two sides will be 3 plus square root 2. And the height is unknown. Okay, question mark. Your task is to find this h. And they give us the volume. So write out the information that you have. So this one is AMath, and of course they expect you to know how to find volume of a cuboid. Okay, so volume of a cuboid is base area times height. So in other words, it's length times breadth times height. Length, breadth, height. So in this case, we're going to do, okay, my volume. Cool, volume. I'm going to write out the formula first. So we will know it's length times breadth times height. But in this case, because the length is the same, so you're going to say, okay, so it will be 3 plus square root 2 square, because the length and breadth is the same. That's why it's square. And then I multiply it by h. The volume, I have it because they give us already. So this side, I will put 19 minus 3 square root 2. So actually, it's very easy for this question. Okay, you want to find h. So you just make h a subject. Since this one is h multiplied, so in other words, I can say, okay, my h will be equals to my volume divided by this 3 plus square root 2 square. Okay, so then how am I going to massage, or rather manipulate this? So a lot of students don't know how to manipulate surds, but actually surds is very easy. Okay, so I'm going to use okay, let me use green pen. Wait. So over here, okay, I put it here. So it's actually 3 plus square root 2, 3 plus square root 2. So you either open up, put two brackets and use a normal rainbow, or you can just use the identity formula, which is the a squared plus 2ab plus b squared. Also can. Yes, the TikTok replay will be uploaded to my YouTube channel, but it will be uploaded on Tuesday. Okay, it will be uploaded on Tuesday. So I shall put as 2 bracket, and I will do rainbow as per normal. So see how I do my rainbow. 3 times 3 as per normal, so it's 9. 3 times square root 2 is just 3 square root 2. So actually the square root 2, you just treat it just like x. You just treat just like x. Okay. This one times this one also give us plus 3 square root 2. And this one, square root 2 times square root 2, you need to know that it just give you 2. So you get a plus 2. And you can see the middle. These are actually like terms. This is actually like terms. So 9 plus 2 is 11. And this one will be 6 square root 2. Okay, so over here, my height now become 19 minus 3 square root 2 over 11 minus 6, 11 plus 6 square root 2. So technically speaking, this is already my height. Okay, but you need to know that we cannot leave surds at the denominator. Can refer to your video during exam. Frankly speaking, I think all of the students hope for that, but that is called daydreaming. Yeah, that will not happen. Okay, you can only refer to my video for revision, okay? I do NT math, but for now this year NT math I'm not doing it already. You can refer to my YouTube channel. Go and search for the normal tech videos that I've done previously. Okay, so I know normal tech N-level normal tech papers are coming, which is in early October, I think. Normal tech, that is a different stream. Okay, normal tech. So you can refer to my YouTube channel and do your revision. This is AMath. Just now someone said, wish that I can be as smart as me. I don't believe that someone, okay lah, sometimes due to genes, some people may be a little bit smarter lah. But I always believe that hard work pay, okay? Hard work pay. Hi, I'm Zach. Okay, I always believe that hard work pays. So, no matter how clever a person, okay, if you don't want to put in effort, eventually also gone. Oh, okay. Wait, give me a while. Let me check something. Alamak. 他讲什么？
他发给你，我叫他打给我，我不会看。
哦。Okay, give me sure, are you simplifying for A and B? Haven't finished, right? I haven't finished. This one is not the final answer yet. Okay, this is not the final answer. Wait, give me a while. It's got some technical problem to settle. Okay, so for those who are new, okay, please go to my Telegram channel whereby you can download the PDF. Okay, and also remember to help me to subscribe to my YouTube channel. 你 send 这个他应该会懂，钱你交他算。Okay. Wow, who so impatient? Ask me faster. Wait lah, I got technical problem lah. So impatient. Okay, now come. Let's do this. So I need to rationalize this. Okay, in order to rationalize, look at this. This is like A plus B. I'm going to make use of the A square minus B square. So A square minus B square is A plus B, A minus B. So whenever you have two terms at the denominator, you rationalize it with the opposite. So now this one is like A plus B, correct? So I need to rationalize it with A minus B. So I'm going to multiply with 11 minus 6 square root 2 over 11 minus 6 square root 2. So actually what we do is, you see, this one and this one is actually times 1. So when I times 1, actually I never change the value. So I'm only changing the presentation. Okay, we are changing, yes, this is one of the certs, standard. What is your Telegram channel, Che? You go to my TikTok bio, click on the link. My last button will go to my Telegram channel. So let's continue. So now you're supposed to rainbow the top. Okay, so 19 times 11. So we will have... Wait, okay, 19 times 11. Okay, let's see. 19 times 11 will give us 209. Did I do something wrong? Wait, let me check something first. Correct. A bit weird. Did I make any mistake? No. Why is it different? Okay, never mind. Let's continue. This one times this one. Next, this one times this one. So minus. So this one will be minus. Next is 19 times 6. So we have 114. So it's minus 114 square root 2. Now this one times this one is minus 33 square root 2. This one times this one is plus. Okay, see here. See this. 3 times 6, so it's 18. Square root 2 times square root 2, so it's 2. Okay, and the denominator, this is A plus B, A minus B. So it's actually become A square minus B square. Okay. So then after that, what we do is, the bottom, you just write something square minus something square. So my A is 11, and then my B is 6 square root 2. So far, okay? I never use calculator. Ayo. When they say without using a calculator, okay? When I said without using a calculator, it simply means that you need to show your working. But of course, this kind of thing, 19 times 11, press calculator lah. Correct? Okay, so what we're going to do is simplify. So 209 plus 36. So I'm going to write 209 plus 36 first. This one is like terms. So minus 114 minus 33 give us minus 147. So this is minus 147 square root 2 over 11 square. So it's 121 minus take a note. This one, 6 square root 2 square is 6 times 6, which is 36. 36 times 2. So this is minus 72. Okay, so I simplify the 209 plus 36, 245. So we have 245 minus 147 square root 2 over 121 minus 72, 49. Okay, high chance is you can divide nicely. Some more you see, they already tell you that A and B is integer. So when you cannot divide nicely and get an integer, that means very high chance that you make a mistake somewhere. Then you have to check. So let's pray hard that I can divide. So 245 divided by 49. 5, good. So I have a 5 here. Minus 147 divided by 49. So it's minus 3. So minus 3, but remember to put back your square root 2. Okay, so this is your height. And so we just put a bracket, cm. And for me, right, I always say, okay, where I will just tell them what is the A and B. Look and compare, see and compare this and this. So A is a number, which is 5. So I will say A is 5. And the B, look at the B here. The B is plus B, but over here I have minus 3. So in this case, I have to say my B is minus 3. If this side is minus B, then I will say my B is positive 3. You understand? Okay, so this is how I do this question. Done. Okay, then let me talk a bit about surds. Okay, all good with this question? Okay, let me talk a little bit about surds. About how to manipulate surds. Cher, do you think from B3, A2 from Prelim can improve to A1? Definitely can. B3 to A2 to A1 in just 1.5 months is definitely possible. There are also people from F9 to A1. It all depends on how much effort you want to put in. Okay, look at this, the surds. So I'm going to talk a little bit about how you manipulate surds. So, for example, when you see square root 8, okay, we must know how to simplify surds. So the 8 you can break into one of the number must be a perfect square. So in this case, the 8 I will break it into 4 times 2. So you can see that 4 times 2 is actually square root 4 times square root 2, and square root 4 is a 2. That's why square root 8, when you simplify, is 2 square root 2. Okay, so actually I'm actually revising the basic. I'm revising the basic. Okay, then look at this one. The number is even bigger. So square root 150. So we always put them into smaller surds. Smaller surds means you put them into like in terms of square root 2, in terms of square root 3, square root 5, square root 6, square root 7. Okay. So in this case, 150, I break it into 25 times 6 because 25 is a perfect square. So it becomes square root 25 times square root 6, and therefore I have 5 square root 6. So in the end, square root 150, you simplify it to become 5 square root 6. Okay, so this is the very first basic you need to know about surds. Okay, then of course this one, just now we did a few times, right? Square root 2 times square root 2, it was 2. So same thing, so square root 3 square, you need to know that it is just 3. Ooh, thanks for the rows. Okay, and this one. So a lot of times, sometimes students don't know what to do. Okay, that's square root 2 times square root 3. So if 2 and 3, okay, so you can just combine. See, so it becomes square root 2 times 3 and it becomes square root 6. It's the same meaning as how I break from here. See here? If I go back, I can also combine. So this is like the other way around. Okay, now let's take a look at this. How to manipulate this? 2 square root 2 times 3 square root 5. How to do? Right? So you do the 2 times 3 first, which is 6. And the square root 2 and the square root 5 just combine, so it becomes square root 10. And square root 10 is already simplified because I cannot break them into numbers whereby one of them is perfect square. Ooh, thanks for the rows. Okay, so in the end, you become 6 square root 10. And 6 square root 10 is already the simplified version. Because if you're going to break the 10 into 2 and 5, it doesn't make, you cannot simplify further. You understand? Okay, so this is the basic. Okay, come back to here. So this is the one whereby just now, similarly, we did the rainbow, correct? So this one, in this case, I did not use the big rainbow. I did the identity. Identity means the A plus B square is actually, so I'm going to just write here. So actually what I use is the a plus b square is actually equals to a square plus 2ab plus b square. So what I used was this one. Okay. And so then massage and you become this, which is exactly just now the question that we did. Okay, so now this type is when it's two different brackets. Okay. Wow, thanks for the rows. Okay, so you just rainbow as per normal. So how to manipulate surds, I already teach the basic at the top, right? So it's just the same. So you see square root 2 times square root 5, we know that it's square root 10. Okay, then rainbow this and this. So the 4 is just times 1, nothing. Square root 2 times square root 2 is 2. So you see my working, I always put 4 then bracket 2. This one is just 3 square root 5. And the last one is 3 times 4, so it's 12 square root 2. Okay, and when you simplify, it becomes this. This one is the simplest form already because square root 5 and square root 2, they are not like terms. So you just keep it as it is. Okay. Yeah, this one is similar. No need to talk about it. Okay, let's talk about the rationalizing. So rationalizing. So just now, I already demoed to you how we rationalize this number 3 types. Where my denominator is like 2 terms. Right? So 2 terms, you will have to rationalize it by the opposite sign. Correct? So, yeah, you need to know that one. So, so basically is using this a square minus b square to rationalize. Understand? Yes, so rationalizing is just this. So when there is one term, it's very straightforward. It's just times square root 2 over square root 2. Okay, then another thing. Look at this number 2. Do you see that the denominator is 5 square root 2? So commonly students always rationalize by multiplying by 5 square root 2 and 5 square root 2. You are not wrong. It's just that later part, the last step, you might need to simplify it again. But you just need to know that rationalizing your objective is to so-called bring your surds to the numerator. So actually, I just need to times the square root 2 and square root 2. I don't need to times the 5, you see. Okay, by doing this, my surds will go up already. So I don't have to multiply by the 5, understand? But you are not wrong even if you put 5 and 5 square root 2, 5 square root 2 lah. Just at the last step, you need to simplify, that's all. Okay, so basically this is the basic of surds. Basic of surds. Okay, so let's move on to number 3. 3 go. Okay, so 3 go, this one is, again, they say without using a calculator, okay, show that cotangent 15 is equals to 2 plus square root 3. Form 4. Yeah, not from Malaysia. So thanks for those who are from Malaysia to help answer the question. Okay, come, let's continue this question. So over here, they say, show that cotangent 15 is equals to 2 plus square root 3. So, see this, this is third letter T. So, we know that cotangent is 1 over tangent. So, the first thing is, I'm going to write cotangent 15 degree is equals to 1 over tangent 15 degree. So, tangent 15 degree, okay, you have to link it to addition formula to make use of our special angle. So we're going to use this formula, which is tangent A plus minus B, which is the addition formula for tangent, is equals to tangent A plus minus tangent B over 1 minus plus tangent A tangent B. So look at the sign here. When here is plus, the numerator, this one is plus. The denominator, this one is minus. When this one is minus, the numerator is minus, denominator is plus. So this is how you interpret the formula. Yes, the denominator is so-called inverse sign. So this is from the formula sheet, which is given. But of course, you need to know how to take it from there. So next thing is this 15 degree. I'm going to make use of special angle. Okay, special angle. So you need to memorize all your 9 ratio. Can you go to my YouTube channel? You can always see the binomial. Go to under my videos and search for binomial. I'm already starting O-level revision, so I'm doing papers already. Okay, I definitely will cover binomial lah, one of the questions lah, but I don't know when So now let's do this So how am I going to do special angle? Okay, look at here So you're supposed to memorize this 9 ratio, correct? You're supposed to memorize this 9 ratio. But Teacher Kangie is very lousy at memorizing things lah. So for me I just need to remember how to draw these 2 triangles. Okay, so special angles are 30 degree, 45 degree, and 60 degree. In terms of radian, it is pi over 6, pi over 4, and pi over 3. Okay, so how do I remember these 3 is by drawing, this is an equilateral triangle. So I'm going to do here. So what you need to do is, okay, you draw equilateral triangle. Okay, so equilateral triangle, you know 60, 60, 60, right? So I'm going to cut it into half. So we know that this side is 60. This side is 30 degree. Equilateral triangle, 3 sides are equal. So 2, 2, 2, 2. So sum 2, and then after this side 2 split into half, so it's 1, 1, right? And this, look at this one side right angle triangle. By Pythagoras theorem, I can find my third side, which is square root 3. So by drawing this triangle, I can already come out with my 6 ratio, which is sine 30, cosine 30, tangent 30. Okay, see here, sine 30. Look at your 30 degree, O over H, half. Cosine 30, A over H. A over H, yes, square root 3 over 2. And tangent 30, O over A, so it's 1 over square root 3. Same triangle, now I look at my 60 degree as my reference. Sine 60, O over H, square root 3 over 2. Cosine 60, 60 right? 1 over square root 1 over 2. 1 over 2, sorry. Okay, tangent 60 is O over A, 60, O over A. So that's why it's square root 3. Right? And we have the last triangle, which is the isosceles right angle triangle. Okay? Isosceles right angle triangle. So I'm going to just draw, okay, I draw my isosceles triangle, right angle. And because it's isosceles, so I know that these 2 angle is 45 degree. And since these 2 sides are equal, I put 1, 1. Pythagoras theorem tells me that this is square root 2. So by drawing this triangle, same, I can come up with my 3 ratio for my 45. So you want to use this 45 or you want to use this 45, it doesn't matter because they give you the same thing. So sine 45, 1 over square root 2. Right? Cosine 45, 1 over square root 2. And tangent 45 is 1 over 1. That's why it's just 1. So I don't memorize this lah. So when I need to use special angle, the trigo ratio, then I draw out the triangle to find out what's my ratio. Now in this case, without using calculator, and they want me to put it in this, I already know that they have to link to special angle. So now 15 degree, now you have to think 30, 45, and 60. Okay, how do you get 15 degree? You have 2 ways. You want to say 45 minus 30 to give 15, also can. You want to say 60 minus 45 give you 15, also can. Understand? So either way. So for what I did was I used tangent bracket. I put 45 degree minus 30 degree. Okay, so I repeat. If you want to use 60 minus 45, also can. But my example, I'm using the 45 minus 30. Okay. I have moderator in the oh my god. Oh, see, mute already. My moderator Okay, so now let's apply the formula. So it become 1 over, okay, I'm going to do this at the side. If not, it's very messy. I'm going to do it at the side so that you see better. Wait, let me find my green pen. So tangent 45 degree minus 30 degree, Apply the formula over here. So it is tangent 45. This is minus, so this one is minus tangent 30 over 1 plus tangent 45 times tangent 30 degree. So be careful, take note, you see here, this tangent A, tangent B at the denominator is multiply. This 2 is multiply. The top part then is the subtract or addition. So after I write this already, then now I'm going to refer to our 3 ratio, our 9 ratio, and then after that, put in the numbers, right? So tangent 45 is 1. Tangent 30, it's 1 over square root 3. So it's minus 1 over square root 3. 1 plus 1 times 1 over square root 3. Okay, so what I did was I just plug in the values. So then a lot of students always panic. Why? Because they don't know how to manipulate this. So, see this, This 1 is actually 1 over 1. So I write as 1 over 1. This is again 1 over 1 plus 1 over square root 3. Yes, no need to memorize the formula. Just learn the triangles, okay? Okay, then after that, what I'm going to do is combine this into a single fraction. Combine your numerator to a single fraction. Combine your denominator to a single fraction. Okay, so don't need to panic. Do step by step. So in this case, my numerator is square root 3 minus 1 over square root 3 over square root 3 plus 1 over square root 3. Okay, then I'm going to write this way. See, square root 3 minus 1 over square root 3. Remember, divide. I can write it here. See, divide square root 3 plus 1 over square root 3. Then you flip. Divide, change to multiply. So square root 3 minus 1 over square root 3 multiply by square root 3 over square root 3 plus 1. Then now you can cancel the square root 3 and square root 3. So you ended up having square root 3 minus 1 over square root 3 plus 1. Right? So this is actually this part. So now I'm going to plug this back into here. So it's 1 over square root 3 minus 1 over square root 3 plus 1. So next time you see that, I got so many fractions within fraction, how are you going to manipulate? So all you need to know is combine single fraction, the divide change to multiply, then you flip, okay? So it's actually not tough. Okay, now this one. 1 over this thing, what is it? Okay, so it is just flip the denominator. The denominator. So it becomes square root 3 plus 1 over square root 3 minus 1. Then, actually by right, we are done, right? Then don't panic. I say, this one and this one is not the same. Then how? Remember, just now we did a search question. We say that we cannot leave denominator. This is 4 marks. 4 marks. This question is 4 marks. Okay, so you need to rationalize this. So remember, I said 2 terms at the denominator. How do you rationalize? Hello, cookies. Okay, so this is a minus b. So that means you're going to multiply with a plus b, remember? And the denominator is simply just a square minus b squared. So it is square root 3 here, and this is 1. As for the numerator, if you notice, this is a plus b. So that means I can use the identity. Hello, a squared plus 2ab plus b squared. So my numerator, it become this one square. Okay, I'm just going to write square root 3 square plus 2ab plus b square. So square root 3 square, you get 3 plus 2 square root 3 plus 1 over square root 3 square is 3. So this is just 3 minus 1. So the denominator is just 2. So I have 4 plus 2 square root 3 over 2. And just nice, both can divide by 2. And that's why it becomes 2 plus square root 3. And this is exactly the same. Do you see that? Exactly the same. So happily right shown. Okay, you can see that my steps is a bit long because some students are weak here. So I go through step by step so that they understand. For those who are very strong, already, you can of course skip some small steps. Okay, I'm going through step by step so that the weak students can catch up as well. So if you find my steps too slow or you are too clever for this one, then you can just swipe away, okay? Okay, I'm just trying to help those who are very weak here. Okay, so now we are done with the question 3a. Now they say, okay, hence, show that equals to this. So I'm going to write here. So cosecant square 15 degree is equals to, I'm going to use the identity. So we have this identity. Where's my pen? Okay, I'm going to just box this up. This is the formula I take from the formula list. And this is the two special triangle I need to draw to find out my ratio. Okay, and one more identity I'm going to use is this from the formula sheet. Cosecant square A is equals to 1 plus cotangent square A. So this is the identity I use from the formula. So you can see that this is cosecant square 15 degree. So it's exactly the same as here. So what I do is I'm going to just change it to 1 plus cotangent square 15 degree. Okay. To be honest, the formula sheet, only the first three identity you need to play around with it, correct? Then the rest is either addition formula and double formula. This one, cosecant square. You look at the question, right? You can see, oh, cosecant and then cotangent. Then you go and look at your identity. The first three identity, then say, oh, you can see this. Then you know that you can relate them. Okay? So now, next thing is you need to know that for trigo, right, when they put a square in the middle, it's the same meaning as 1 plus cotangent 15 degree, the whole thing square. So it is the same meaning. And cotangent 15, if you recall back, our front part, we already do it. When you see the word hence, you already know that you need to take from the part A. So please don't go and redo the whole thing again. Just plug and take this 2 plus square root 3. So it's 1 plus 2 plus square root 3 square. And I'm going to rainbow this one. So it becomes 1 plus 4 square root 3 plus 3. Simplify it, I get 8 plus 4 square root 3. They want you to prove that it's 4 cotangent 15. So I just need to take out my common factor 4. And this is this, which is this. So therefore, it is equals to 4 cotangent 15 degree. Shown. Done. Right, so this question, part A is 4 marks, part 2 is 2 marks, total 6 marks. Can. If you don't know how to do part A, okay, touch wood really cannot do, just straight away use the this side. Right, you can use it, can straight away use it. Yes, part A harder, but actually, to be honest, it's actually just applying the addition formula. So practice make perfect, understand? So if I'm going too fast and you're already lost, try to understand 30, 40, 50% is better than nothing. Then on Tuesday onwards, you can refer to the TikTok replay. Okay, and then on my YouTube channel. And then after that, from there, you'll be able to see the replay. And then you watch again, then you try again yourself. Okay, that's how you learn. Sure, should I start doing prelim papers or TYS? Do TYS first. From the because once a TYS, if you cannot even handle TYS, okay, when you do TYS, you are like having a feel of how the O-level questions is like. Okay? So if you cannot even handle TYS question, prelim papers will be tougher for you. Agree? So it's like, okay, you at least master yourself with the TYS, which is the past year O-level questions. You know how the questions are like. Okay, practice, and then after you know what topics you're weak at, then you go and find out how to do those the topic. Settle it by topical. And then after that, you can settle by the yearly. And once you feel that TYS is too simple for you already, then yes, you can go and do prelims. Yes, prelims are always harder. So always do TYS first. Okay, because you're going to throw yourself to do prelims, and then you haven't even handled TYS, and then after that you kill yourself and say, oh, prelim so difficult, then I feel so not motivated. Okay, you need to know that prelim, I always tell my students, if your prelim is very tough, it's because The school cannot give you easy prelim. If you score super well for your prelim, then maybe you will just, I'm super ready for my O-level. Then you start to slack and you just wait for the O-level. You don't do your practice. So usually prelim, they will give it very tough, okay? Then after that, they will make you scared, okay? Scared already, never mind. Because then you will know that, okay, I need to pack up and then I have to revise for my O-level. Okay, that's what they are trying to do. So if your prelim did very bad, O-level is still Cambridge, yes. So if your prelim do very bad, it's time for you to really pack up. But do TYS first. Handle TYS, make sure you are okay. You roughly know how the O-level questions look like. Then you can do prelim for further practice. Okay, let's move on. So we are done with this trigo question. Next, logarithm. Logarithm, Wow, today actually I'm going quite fast also. I don't know. Okay, Scully, I never even hit the 2 hours. Never mind, let's just see what is it. Okay, question number 4, logarithm. Okay, so before I start the logarithm, let's recap a bit about logarithm laws. Ta-da! Okay, so let's take a look at today. You're going through area under the curve and kinematics. No. After these logarithm questions, the next one is trigo graph. Yes, and that will be the end for today. Okay, if you want to recap area under the graph, area under the curve, last week I did area under the curve, right? Kinematics is I think last week. You can go to my TikTok, you can go to my YouTube channel and see. Okay, so now let's take a look at this logarithm. So some rules or laws of logarithm that you must know. So power law, standard So when there's a number 2 in front, you can bring it to the power. Okay, you can see that you bring it up, so it becomes b squared. So that is the first law. Quotient law. Okay, something so-called a bit strange about logarithm. It's, okay, logarithm when you minus, okay, when you combine, must be same base, same base, When you combine, then it becomes b divided by c. So it's like minus, combine, divide. Product law is plus, combine, multiply. You can only do that when it's the same base, same base, Logarithm is one of my favorite topic. Yeah, Sec 3 AMath topic, logarithm. Can tell you this is a killer topic. A lot of students hate this topic. Okay, because there's so many law, then they get very confused, okay? But actually, it's quite a fun topic that I personally love it. Okay, then the next thing is you must know here the A is your base How the square belongs to the A? Correct or not? Later I show this part. This is a different thing. But currently now this A is your base. There's only one term here which is B. So the square of course only belongs to the B . Yes, Cookie Mommy, I know what you're referring to, this one. Later I'll talk about this one. Okay, so now you need to know how to convert between logarithm and index form. Correct? So log AB equals to C. This is the logarithm form, right? So you need to change it to index form. Push up. So this is, I always tell my students, push up. Like that. You're like pushing up the C. So it's A to the power of C is equals to B. Push up. You're trying to push up the C. Right? A, push up the C. So A to the power of C is equals to B. So you need to know how to convert between index form to logarithm form to index form. This is a very, very, very important skill you need to know. Okay, change of base. Another super important rules that you need to know. Okay, so this is like log AB, for example, right? So you need to change to base. Change of base. So I want to change to base C. So just write, okay, base C. Then after that, the B is at the numerator, the A is at the denominator. So let me just give some example. So this means like, for example, if I have log, let's say 3, 5. Okay, I want to, let's say, change to base 2, for example. Just an example only. I want to change to base 2. So I put, okay, base 2. My 5 is at the top. My 3 is here. So this is how you change of base. You understand? Okay, but of course, a lot of students always ask, change to what base? Change to what base? It depends on the question. If your neighbor is like base 2, of course you change to base 2. If your neighbor is base 5, of course you change to base 5. So there's I cannot give you a definite answer, change to what base. Okay, then how about, let's say for example, if they say find the value of log 5/8. On our calculator, we only have these two buttons over here, log and ln. Okay, so a bit cute thing is on the calculator is log, but log represent base 10. Okay, so this log on the calculator actually is lg. I mean as in the neighbor depends on the question itself, what's the neighbor terms. Okay, ln is base e. So over here, I'm going to put here, okay, I'm going to, I never write this one. Special, so-called special logarithms So you need to know that, okay, base 10, it is base lg. When you write lg, it's actually base 10. Loge, base e. We write it as ln. Okay, this one is log on the calculator. Okay, don't come and tell me, hey, where's the ln now? Hey, what is ln now? What's the base of ln? Ln is actually base e. Log is base 10. Okay, and because calculator can only press base e and base 10, so when let's say for example they ask you to find out what's the value of log 5/8. So I make use of change of base. I change to base e, which is ln. So over. So ln 8 divided by ln 5. So this one, to find the value, you just key in ln 8 over ln 5. And be careful. You see, this is fraction. Ln 8 over ln 5. Okay? Which is this value. You don't go and say, you don't go and put like that. You don't go and put ln and after it give me 8 over 5. This is two different things. Okay? Okay, so now let's come back to here. Just now a student asked about whether the square belongs to the b. For this case, it's very straightforward because there's only one term here. Okay, this one. See here, log ab squared. Do you see that my 2 only belongs to the b? Okay? So when it's such situation, you cannot bring down the 2 to in front. You see here? So many students, okay, then I bring down the 2, power law, bring it down. But I cannot do that because why? Because the 2 doesn't belong to the AB. I mean, doesn't belong to the A. Unless you have this. See here. AB with a bracket 2, right? Then in this case, the 2 power belongs to both A and B. Then yes, you can bring down the 2 in this way. You understand? So this one have to be careful. You have to be very careful. Yeah, this calculator cannot be used for O-level. Yes, I know. But the button is the same lah. Button same lah. Okay, the log button and the ln button is the same. Okay? Okay, now some special property, so-called properties of logarithm that you have to know. So over here, okay, every time when we solve logarithm equation, every time we solve equation, in fact, whenever we solve our unknown, we must always put back the unknown back into your equation to check whether is it valid. Because if it's invalid, you need to reject, right? Invalid, you need to reject. So now, see over here. So the rules is, my A and B, both A and B must be positive. Okay, my A and B must be positive. That's first thing. Second is, my A got an additional rule, which it cannot be 1. So some students ask me, why cannot be 1? Why cannot be 1? Very easy. Let's come back to here. Remember just now we changed that to index form. You imagine my A is 1. Okay, if I push up, 1 to the power of anything is 1. So it's meaningless, right? It's meaningless. So that is why our A, we cannot accept 1 as well. Okay, so this is one rules that you need to check to see whether you need to reject value. Next, the very important one is log AA. When these two numbers is the same, it is equals to 1. So, for example, okay? So, if I tell you ln E, the ln is base E. So, this ln E is actually log EE. So, we know that it is actually 1. Same, if I say log 10. Log 10, if I review the base, it is log 10. So, actually, it's also equals to 1. So, this is the meaning of this. So, it means that if I have log 2, of course, it's 1. Log 5 is 1. This one. Okay, so this one. Log A1. As long as this number here is 1, it give you a 0. Okay, why is that so? You see, if I'm going to change it back to index form, push up. A to power of 0, whatever the A is, anything to power of 0 give you 1. Agree? Hello? Right? So, all these are the important things you need to know about logarithm. Okay, so I so-called recap and revise about logarithm already. Whatever you need to know is all in this page. So, you want to screenshot whatsoever, please go ahead. Because I'm not going to scan this in. I'm only going to scan the solution to the Telegram channel. Yes, please screenshot. Okay, please screenshot because these notes I'm not going to upload. I'm only going to upload the solution to the questions that I go through. Okay, I count 1, R2, R3, R1, R2, R3. Okay. Move. Okay, now let's do the logarithm question, which is question number 4. Okay, so now let's see. So now they say solve the equation. So I write out the question first. So it will be 2 log 3x plus 4 minus log 3x plus 2 equals to 2. This is a 5 marks question for 4A. Can you find the value of my heart because she broke? You talk rubbish, later my moderator block you. You cannot block already. It will be easy for me to understand then. Never mind, new masters, you still can recommend to your juniors, you can still recommend to your friend, kids, that I'm teaching live. Okay, come. So, let's take a look at this one. So, first, every time we want to solve logarithm equation, we try to make them into single logarithm. So, this is like, okay, this is like 2 terms here. So, I want to combine. Yes, I want to group the log 3 together. But before I group, I have to bring these 2 up first. Yeah, Wesley Thomas, I also agree. Last time we also don't have. Now they got so many resources. Okay, so power law bring up. So I have log 3 x plus 4 square minus log 3 x plus 2 equals to 2. Okay, there's also another way of doing it is sometimes students change the 2 into logarithm as well. It's like, okay, I can put this as 2 log 3, 3. Okay, also can do that. But for this example, I'm not doing that because later after I do my single logarithm, I can push up and just change to index form. So now, over here, see, same base, right? And it's minus. Remember just now I said the quotient rule is become divide. So it become log 3 x plus 4 square over x plus 2 equals to 2. Right? So what I'm going to do is change to index form. Push up. So I have x plus 4 square over x plus 2 is equals to 3 to the power of 2, which is 9. Now, do you see that both sides already single fraction? So now I can cross multiply. So cross multiply, I have x plus 4 square equals to 9 rainbow with x plus 2. And now this is just a normal AMath solving quadratic equation. So do your expansion for this one. So this will be x squared plus 8x plus 16, 9x plus 18. This is a quadratic equation, so you throw everything to the left hand side. So x squared plus 8x minus 9x plus 16 minus 18 equals to 0. I'm going to continue here. So we will have x squared minus x minus 2 equals to 0. So you can use quadratic formula, or you want to do the cross method factorize also can. Log bring to the right. Index form, that's why. The 9 is 3 to the power of 2. Push up, see this? Push up 3 to the power of 2, so it's 9. Okay, I just put here lah. This one push up, so it's 3 to the power of 2 equals to 9. In case you're wondering why is it 9. Hoi, hoi. Okay, so let's factorize this. So in the end, it becomes x minus 2, x plus 1 equals to 0. So we have x equals to 2 or x equals to negative 1. So some students, they see, oh, negative, reject, reject, reject. Okay, they see negative, they reject. No, not say you get a negative, you reject. You must always put back into the original equation. Why we don't use log 3 squared? Oh, also can. Forgotten PC, you also can do that. Just remember just now I say, some students change the 2 to 2 log 3. Okay, for me, I never change because I know that I can easily just do index form. It's the same meaning, It's the same meaning. So now let's put back the x into the original equation and see whether is it valid. Whether does it fulfill this condition over here. Okay, does it fulfill? So now let's take a look at the 2. 2 plus 4 is 6, valid. 2 plus 2 is 4, valid. So this one can accept. Okay, this one minus 1, Minus 1 plus 4 is 3. Positive what? So it's valid. Minus 1 plus 2, 1. Valid what? Because I can still log 3, 1, which is 0. But it's still considered valid. So although this is negative, but when I put back into the original equation, my logarithm is valid. So this is also accepted. AMath no calculator. Why AMath no calculator? Wait. Just now someone asked what? Where the 2 go from line 2? Where the 2 go from line 2? Here. Power law. Remember? Power law. I can bring the 2 up. So the 2 is here. See here? Okay. So we are done with this question. So just now, some student asked about whether this one 2 can change or not. Actually, I also can do this as in like, I want to change this to, let's say, log 3. Just now remember log 3 is 1. So I can put it as this way also can. So imagine, if this is here, you just remove the log 3, it is also equals to 9. It's the same thing. Agree? So it's actually the same thing. So just now some student asked why I cannot do this, right? So you see, it's actually the same thing. I can just put alternative lah. Also can. Okay. So we are done with the question 4A. 5 marks, 5 marks. But it's not tough, It's not tough, Oh no, I don't do primary school math. I do focus on secondary school. Yes, different base now. Okay, but this one we are going to use change of base, but we're going to use change of base plus substitution. Okay, see here. So I'm going to write out the question first. So I have log 5y minus 3 log y5 equals to 2. So again, okay, the first thing is when I see 5y, y5, like that, so I'm going to change of base. Okay, so some students, many students always like to ask me the question, whether I change this to base y or should I change this to base 5? Okay, I don't do H2 math. Okay, you only change to the base with number, so you don't change to make your base to be y, understand? So I'm going to change this. So log 5y remain. This one you put a bracket. change of base. Remember just now I teach you change of base? Okay, now I want to change to base 5, okay? So you put in your base 5 first. So this is log 5, and my 5 is at the numerator, my y is at the denominator. All good? Okay, then remember log 5 is what? 1. And this 3, when you multiply, it only belongs to the top. It doesn't belong to both. Because it's like 3 over 1. It only belongs to the top. Common mistake is student multiply to top and bottom, which is wrong. So now over here, log 5y. So since this one is 1, so I shall rewrite as 3 over log 5y equals to 2. So in this situation, don't go and do, I go and do combine to single fraction, blah, blah, blah. No. Why? Because this log 5y is complex enough. So I'm going to make use of substitution. So I'm going to say, okay, I'm going to let the log 5y equals to u first. I temporarily let the log 5y equals to u. So in the end, I get u minus 3 over u equals to 2 over 1. So now I simplify the equation. Cut what? Don't understand. Mid 60, what? Cut what? You want to cut what? Okay, so now you want to solve this equation. So this is like, okay, I'm going to multiply by u throughout. Multiply by u throughout. So I have u squared minus 3 equals to 2u. So u squared minus 2u minus 3 equals to 0. So I end up having u minus 3, u plus 1 equals to 0. So I have u equals to 3 or u equals to negative 1. Same. Students always use substitution. Then after they solve the u, oh, happily done. Then they finish it. Huh? What thing? No, it's minus. Oh, some student ask whether this one can cancel, This one can cancel or not? Cannot, because this is minus. Unless this is multiply, then yes, you can cancel this and this. But this is minus. You cannot cancel. How do you do the third line? This one? Log 5 is 1. So 3 times 1, so this is 3. Clarence can? Clarence 88. Do you understand? Log 5 is 1. And 3 belongs to the top, so it's just 3 over log 5y. Okay, so we're not done yet. We got to pull back our log 5y. So it means that, okay, log 5y is equals to 3 or log 5y is equals to negative 1. Please explain the bottom one. Which part? I don't understand. Which part? This one? Yes, because your objective is to solve y. Okay? It's just that this side is complex, so we just temporarily use u to represent the tough one, which is the same term. And then we solve it as per normal first. Then we pull it back and then we solve the y. So we are not done yet. So we want to solve the y. So y will be equals, push back to index form. So it's 5 to the power of 3. Y is equals to 125. This one, y is equals to 5 to the power of negative 1, push up. So y is equals to 1 over 5. And we are done. So these two, both are positive. Also check. You see, you put back into the original equation, 125 or 1/5 put here, it all works. It's still valid, the condition. So both are accepted. Where do you get the u squared? Here. Okay, so let me show you the so-called long method. Long method. See here. Here, do you agree that this is actually u over 1 minus 3 over u equals to 2 over 1? So let's combine this into a single fraction. Time u. So it is u squared over u minus 3 over u equals to 2 over 1. combine this into a single fraction. U square minus 3 over U equals to 2 over 1. Cross multiply, U square minus 3 equals to 2U. See, it's exactly the same. Do you see that? Do you see it's exactly the same? See here and here, exactly the same. So what I did was, because the common denominator, the LCM is U, so I just do a times U throughout. U times U give me U square. 3 over U times U give me 3. 2 times U so give me 2U. Do you see that? So this is the so-called shortcut. Just times the LCM. But if you cannot understand this part, you want to combine into a single fraction and then cross multiply, it also works. It's exactly the same. Exactly the same, Right? Okay, so this is how you do this question, All good. Any parts need me to understand? Meet 60 can, Okay, let me drink water. So, while waiting for me to drink water, can you help me to like and share? Okay, and if you all still have questions on this question B, whether part A or part B, you can ask. But when you ask, not understanding it, those who don't understand, you have to tell me what you don't understand. If you tell me don't understand, I also don't know what you don't understand. Then I also don't know how to explain, okay? So if you don't understand, tell me which part you don't understand, I explain. Log is always harder than surds. Yes, this is definitely, because surds actually just now, like I said, the only tough part about surds is you just need to know how to manipulate surds. And then the rationalizing part. So actually surds is quite straightforward. Okay? Logarithm has many laws, especially when you have this quotient law and product law. Okay? When it's a little bit confusing, is minus combine become divide. Plus combine become multiply. Okay? And then you still have the change of base. So yes, logarithms is more complex because there's more law, but actually the laws are always the same, they don't change. So practice make perfect. If you do a lot of practice logarithm question, you realize that they're always asking similar questions. Okay? Part A, can you please explain how you got from line 3 to 4? Okay, let's see. Okay, part A, line 3 to line 4. Okay, so what I did was 3 to the power of 2, index form. I make use of this. See here, Here, index form. I push up A to the power of C is B, right? See here, push up 3 to the power of 2 is this. And 3 to the power of 2 is 9. Hayomide, can, correct? Understand? Where do you get the U square? Do you multiply through by U? Yes, I did. See here, I times U, I times U throughout, so U times U, U square. How to get part B line 2? Change of base. So what I did was I just changed this log y5, see here, log y5, I changed to base 5. Change of base is here, see here. Log AB, I can change to any base I want. So let's say I want to change to base C, and then the B goes to the top, the A go to the bottom. So in this situation, I'm changing this to base 5. So you see, I put a bracket, put a fraction. I want to change to base 5. So the 5 goes to the top, the Y goes to the bottom. Yes, you can screenshot this. Please, can you explain how change of base work? Can. Wait, see here. So take a snapshot if you need to for the laws. Take a screenshot if you want to. Okay, one by one. Okay, let's see. If U multiply through by U, 3 over U multiply by U will give you no. 3 over U times U give you 3. Okay, let me settle one by one the questions first. Wait. Okay, first let's talk about the part whereby someone just now said 3 over U, when I times U, it becomes 3U. No, see here, 3 over U, when you times U, cancel, it is equals to 3. Agree? So I resolved that already. Okay, so now change of base. If today, just now, I'm trying to change log 5y into base 5. So I put it into a fraction. I want to change to base 5. Why I change to base 5 is because the neighbor, just now remember I said neighbor, because my neighbor is base 5. It's redundant if you go and change to ln or log or base 3 or whatever base, because my neighbor is base 5. So I change to base 5. So you put log 5, because I want to change to base 5, and this 5 goes to the top, this y goes to the bottom. So this is how you change of base. And log 5 is the same as log AA, which is 1. So this is 1 over log 5y. Agree? So this one, change of base, is how I change this to the 1, the 1. And the 3 belongs to the top, so 3 times 1, that's why this one is 3. How you get the y value at the end? Later I settle that one. Okay, I resolved the question already. So just now someone asked, how do I get the y in the end? So what I did was again change of base. See here, after I resolve my u equals to 3, u equals to negative 1. So I pull back because just now I let my u equals to log 5y, agree? So log 5y is equals to 3 and log 5y equals to negative 1. So what I do is change to index form. Push up, see? This one push up. 5 to the power of 3 equals to y. Push up. 5 to the power of negative 1 equals to y. And 5 to the power of negative 1 is 1 over 5. And that's how I get my 2y. Okay? So we are done with this logarithm question. Sure, if you see someone explain in the comments, I don't think you need to explain. I don't think you need to explain, so we can move on. Got someone explain me? I mean, if someone asks question, I will answer the question. But unless someone help me to explain, then I don't have to explain. Okay. I don't know why it's called y equals to sine x. Later I'm doing trigo graph. Soon. Next question. So we are done with this. No more question for this question number 4. Okay, let's move on. Question number 5. So now we're going to do trigo graph. Okay, trigo graph. Okay, before we're going to do this question 5, let me recap on trigo graph, sine graph, cosine graph, and tangent graph. Okay? Ta-da! Beautiful graph. Okay? So now let's take a look at forgotten PC. Okay, no problem, welcome. Okay, see here, sine graph. So I'm going to recap on the basic graph, which is y equals to sine x. Okay, so the amplitude is the number in front of the sign. In this case, is 1. So amplitude is 1. The period is 360 degrees divided by 1. The 1 is the coefficient of the x, which is 1. So 360 degrees divided by 1, so it's 360. The shift is 0. There's no shift. There's no plus or minus number here, so there's no shift. So come back to here. So this is how we draw the graph for sine graph. So you can see y. Okay, so you see how I do. 360 is 1 cycle. And then after that, half, which is 180, cut into 4 parts. In other words, cut into 4 parts. So I have 90, 180, 270, and 360. Next is, I always tell my students to plot the 5 critical points. So, sine graph start from 0. So you mark out 0, you go up to the max, go down back to the 0, go down to the minimum, go back to the 0. Mark out the 5 critical points first. Then you can draw the shape. Okay, and I tell students that how you draw a nice graph is you have to make sure that your interval are equal. You can see my interval are equal. I don't put small, big, and then the shape will go rough. Why never use radian? I show the degree one first. Radian later part. You see here, I got show 4 pi and 2 pi 1 radian. Okay, so sometimes, of course, the x-axis, they will ask you to draw in terms of degree. Sometimes they ask you to draw in terms of pi. So you have to see what they ask you for. If they ask you to draw from x between 0 to 360 degrees, of course, you give your x-axis in terms of degree. If they ask you to draw from 0 to 2 pi, of course, you give your x-axis in terms of radian, which is in terms of pi. Okay, so this is the sine graph, the very basic sine graph, which is when the amplitude is 1, the period is 360. Okay, so now let's do a little bit of shift. So look at over here. Y equals to 3 sine 2x. I always get confused on whether to start at 0 or the shift number or the amplitude. Okay, the shift is 0, you start from the x-axis. That is your middle line. When there's no shift, your middle line is the x-axis. So now, later part, you see I do the shift. Later I talk about the shift. So now let's talk about the amplitude change as well as the period change. So now you see, I do one example, which is 3 sine 2x, right? Okay, so my amplitude is the number in front of the sine, so it's 3. My period is 360 degrees divided by the coefficient of the x, so it's 2, divided by 2. So 360 divided by 2 is 180. So that means in 180 degrees, you will see one cycle. And in this case, the shift is 0 because there's no plus or minus here. So when your shift is 0 means your middle line is your usual x-axis. I will talk about tangent graph later, step by step. I'm now doing sine graph. So please listen. Okay, so now, see here. So how do you start drawing this graph? Always find out all these 3 important information first. So in this question, okay, they asked to draw up to 360. So I know I need to draw 2 cycles. Okay, I need to draw 2 cycles. So we always draw 1 cycle at a time. So I mark out 180 first, cut into 4 parts, 4 intervals. So I know that one small interval will be 45. So 45, 90, 135, 180. And you have to put in your maximum and your minimum. In this case, there's no shift. Since amplitude is 3, so the thickness of your graph is 3. So you see, the max is 3, the minimum is minus 3. Okay? Once we have all these things ready, now we can mark our 5 critical points. Sine graph start from 0, and your 0 is your middle line, which is your x-axis. 0, max, 0, minimum, and 0. The 5 critical points. Then you can draw the shape already. So once you're done with 1 cycle, you do the same for the second cycle. And the second cycle, how do you do is you already know one interval is 45. So from the 180, I plus 45, I get 225. 225, I plus 45, I get 270. 270 plus 45, I get 315. 315 plus 45, I get 360. That's how I get all the numbers here. Then now, you see, I cover this side. Right? So same thing, draw the 5 critical points. 0, max, 0, minimum, 0. Then you can draw the shape. And we are done. So I draw this graph with amplitude 3. No shift, so the middle line is still at x-axis. This one, because it's 2x, so we draw 2 cycles in 360, because the period is 180. So this is how you draw this. Okay, next. Increase the difficulty again. Right? So you can see that in this case, do you see that I have a plus 2 already? The x-axis should be in radian because degree are not real number. No. The x-axis not necessary to be in radian. It depends on what they ask you to draw. If they ask you to draw from 0 to 360, you give in degree. if they ask you to draw from 0 to 2 pi, you put in radian. Okay, so over here, now I have a plus 2. That means now my shift is no longer 0. My shift is 2. So now your middle line is no longer x-axis. Take note. Your middle line is no longer x-axis. So the first thing is I draw my y equals to 2. My new x-axis. So take note that your new x-axis must be dotted line. Dotted line. Okay, now next. Do you see that here is minus 2? Okay, many students, every time this kind of question, they ask you what's the amplitude, they will put amplitude equals to negative 2. The intervals just now, I did explain. Like for example, this one, you know one cycle is 180 degree. So 180 degree divided by 4 lah. You know that 45 degrees. So you know the interval is 45. Okay, later I'll talk about the radian. Okay, so now over here, take note, when this one is minus 2, my amplitude is still 2, because amplitude is your thickness. So it's still a positive value. But this minus represents something. This minus represents that you need to flip your graph. So I always tell my student, no, amplitude is 2. The minus simply tells me that my graph is flipped. That you see my sine graph is no longer this direction. My sine graph go the other direction. So this one have to be careful. Amplitude must put positive 2. Then you just put a bracket here, flip. To remind yourself later when you draw your graph, you need to draw a flip graph. Okay, period. So do you see that the coefficient of x is half? So the period in this case, because they asked to draw from 0 to 4 pi. So I need to do 2 pi divided by half. If it's in terms of degree, you take 360 divided by half. But in this case, we are doing in terms of radian. So I take 2 pi divided by half, so I get 4 pi. So that means period is 4 pi. If they ask you to draw up to 2 pi only, you only draw half cycle. But in this case, I'm demonstrating drawing 4 pi, which is 1 cycle. Okay, so now middle line. So just now someone said very confused with on the where to draw, right? So my new x-axis, then you need to know what's your maximum and minimum. My amplitude is 2. 2 plus 2, 4. 2 minus 2, 0. So the thickness is 2, which is the amplitude. So once you have your max and your minimum and your middle line ready, as well as the x-axis, so my one period is 4 pi. 4 pi divided by 2 is 2 pi. 2 pi divided by 2 is pi. My one interval in this case is pi. The period is number of cycle. No, period is one cycle is, this one 180 degree will have how many cycle? In this case, 100, okay. In this case, 4 pi. So that means 4 pi is one cycle. Do you see? One cycle only, ma? Okay, so once you have the interval ready, your max, middle line, and the minimum ready, now plot the 5 critical point. So this is a little bit different from the usual sine graph is because this is flipped. So usual sine graph is 0 max, 0 min, but flip. So it is 0 min, 0 max, and 0. So plot the 5 critical point. 0 is in your new x-axis, your new middle line. Minimum, 0, max, and 0. So once you have the 5 critical point, doing, done. Perfect drawing. Yes. If one cycle is until 180, have to draw 2 cycles to reach one. Yes, correct. If your one cycle, you see here, just now my period is 180 degree, right? So you see, 180 degree, you only see 1 cycle. So if the question asks you to draw up to 360, you got to do 2 cycles. But if the question asks you to draw up to 180, then you only draw 1 cycle. Okay, so this I have demonstrated about the flip. I have demonstrated about the sheaf. Okay, so now let's do a little bit more, which is also similar, but this time around my sheaf is shift down. Do you see that it's a -1? So same concept, look here. First, my amplitude. So the amplitude is always a number in front of the trigo. So in this case, it's 2. The period is, because I'm doing in radians, so it's 2 pi divided by 1. So my period is 2 pi. How to know we need to do till 360? The question will usually tell you. Like later you see wait. You see, usually they will give you a range. They will tell you for what interval, then you will draw up to where. Okay? So let's continue this part here. Okay. Yes, definitely. You must know the sine, cosine, and tangent graph shape. Okay. So now, see here, amplitude 2. Period 2 pi. Shift. This time around is -1. I mean, some school or some teachers always ask students, let's say got the -1 or +2. They go ask them to draw the original graph without the shift. Then after that, the last step, then they shift the graph. They will say that, okay, you draw this one, and after that +2, then you shift up by 2. Okay, then this one, oh, you shift up by 1. But I find that very troublesome lah. So, so this is my way of drawing my trigo graph, which it has never failed me before lah. How to know what the x value will be the max and minimum point? No, you see, do you see that every time one cycle is always 4 interval? Okay, every one cycle is always 4 interval. And the 4 interval will have 5 critical points. So you need to know that sine graph is 0, max 0, minimum 0. So when you have the 4 points here, so naturally this one is the 0. The next interval is the max. The next interval is the 0. The next interval is the minimum. The next interval is the 0. Why isn't it flipped if it's a -1? Do you see that this one -2 is in front of the trigo? This -1, you see, if this one, if you rewrite, isn't this 2 sine x -1? The number in front of my trigo is +2. It is not -1. This is just like, oh, I purposely write the -1 here to confuse you. Right, Nikam 16. Do you understand why is it that it's not flipped for this one? Because the number in front of the sign is +2. So this one's no flip. The -1 is the shift, which is the -1. Okay, so now we are ready to draw this graph. So my shift is -1, so we need to find our new middle line. So my new middle line is the y equals to -1. So you see my dotted line here. Next, my amplitude is 2. So I need to know where is my maximum and where is my minimum. Okay, so -1 plus 2 is 1. -1 minus 2 is -3. So my max is 1, my minimum is -3. Okay, because my amplitude is 2. So the thickness is 2. The thickness is 2. And because period is 2 pi, so 2 pi, pi over 2, and pi over, this one is 3 pi over 2. So sometimes students ask, how to do the interval, especially in terms of pi. They're very confused. Do you see this is pi over 2? My one interval is pi over 2. Pi over 2 means remove the pi is half, right? So my one interval is actually half. So how I get this 3 pi over 2 is I can just take 1 plus 1.5. Sorry, 1 plus half is give me 1.5. So I know it is 3 pi over 2. Okay, my interval is like half lah. The pi you can add it manually yourself. Is the shift always the new x-axis? Yes, the shift is always the new x-axis. Okay, so once I have my shift, which is the so-called new x-axis, the new middle line, my max, my minimum, and my 4 intervals are ready, now I can start to draw. So this is a normal sine graph. So it start at 0, which is my new 0. 0 here, maximum at the next interval. Go back to 0 at the next interval, go down to minimum at the next interval, and go back to 0 at the next interval. Once you have the 5 critical points, you draw the graph. Okay, so this will be the different scenario for sine graph, okay? So I draw the basic one. I draw one with its change of amplitude as well as the period. I do one which is the flip graph and also a positive shift. I do one which is the negative shift. Okay. How do you if the middle line is -1 again? Okay, see here. So if my middle line is -1, you just draw the dotted line y equals to -1 here. And because my amplitude is 2, so -1 plus 2 is 1. So that's my maximum. -1 minus 2, because my amplitude is 2, so my minimum is -3. The period is 2 pi. Because I take 2 pi divided by 1. The 1 is the number in front of the x. So my period is 2 pi. How do you know where to start with on the x-axis? Huh? I don't understand. How do you know where to start with on the x-axis? I didn't start from the x-axis. My new x-axis now is my y equals to -1. Wait lah, I'm going to go through tangent graph and cosine graph soon. Okay, so now I'm done with recapping and revising sine graph. The shift is here. +2 means the shift is 2. -1 means the shift is -1. Okay, it's like, okay, I draw this graph and then my graph is shifted down by 1. So the shift is -1. This one is, okay, my graph, then after that I +2 means that my graph is shifted up by 2. So my shift is 2. Okay, so we are done with cosine graph. Next, we're going to go through cosine graph. Ta-da-da-da. So it's similar to exactly what I did for my sine graph. The only difference is the shape of your cosine graph. How do you know it's pi or degree? The question will state whether you want you to do in degree or radian. Yes. All this will be uploaded. No. The video today, the TikTok live will be uploaded to the YouTube channel. Okay? But take note, these notes I'm not going to upload to my Telegram channel. So you want, you can screenshot. Okay? Okay, so now let's take a look. Cosine graph. I draw the y equals to cosine x, which is the basic one. Same. Amplitude is 1. Period 360. Shift is 0. So, similar. It's similar. The only difference is sine graph start from 0, max 0, min and 0. Cosine graph start from max 0, min 0 and max. That's the only difference. Okay? That's the only difference. Other than that, the rest is similar. So, we do the same. Now, the next one is y is 3 cosine 2x. Okay, I will go a little bit fast on the cosine graph because it's similar to the sine graph. The only difference is the shape. Okay, I'm going to talk about tangent graph later part. So, same thing, amplitude is 3. So, my period in this case is also 180. So, you see, I always draw one cycle at a time. But if the question asks you to draw up to 360, you don't be so ambitious to draw both. So for me is, I know I want to draw 2 cycles, so I give some space to it. But every time I always draw one cycle at a time. So you draw your 180 first, mark out the 4 interval. Okay, and then after that, put in your max and minimum. Amplitude is 3, so from 0 plus 3, 0 minus 3. So my max is 3, my minimum is -3. And then you put in your intervals. Okay, so now with all the intervals and your max and minimum, you are now ready to plot the 5 critical points. So cosine graph start from max. So maximum, 0, minimum, 0, and maximum. So that's how you draw the cosine graph. Oh, yeah, okay. I want to talk about the cosine graph about a little bit on the shape. So a lot of time my students power leh. Their cosine graph looks like that. Okay? Cosine graph, you must know that the 2n is very important. It's curvy. It's not like that. So a lot of students struggle to draw the... Yes, it is always divided by 4 to find the interval. So my students always struggle to draw the corner. So I show you how you draw the corner. See, when you need to, okay, let's say I have my interval here. Let's say this is 360, this is 180, this is 90, this is 270. Let's say this is the 1, let's say this is the minus 1. Okay, so how am I going to draw the corners? So cosine graph start from maximum, 0, minimum, 0, and maximum, correct? So then students see here, wow, they always struggle to draw the corners of the cosine graph. So how do you draw the corners is, you visualize that you are drawing this way. You see, it's just like that. You want to draw sine graph, is it like that? So when you draw the corner, the curve, you just visualize that you're actually completing a sine graph. So, but of course, you don't need this. Okay, you don't need this. What I'm trying to say is when you draw it, you visualize that way. So then after that, this way. Okay? Then same thing, this corner, don't panic. Don't panic. Just visualize that you're drawing it continuously. Correct? If you're going to draw the continuous, so you just, oh, okay, like that. Then, of course, you don't draw lah. Correct? So this is how you do the corners, understand? This is how you do the corners, Amplitude is the thickness, it's not the maximum or minimum, Okay. This is how you draw the two corners, So I talked about the corners already, Okay, let's come back. So just now we are done with one cycle, but we know that we want to draw for up to 360 degrees. So I do the same thing. So my interval is 45, 180 plus 45 plus 45 plus 45 plus 45. The 4 interval, plot the 5 critical points, then draw your shape. And you're done. Yes, cosine graph, a lot of students always like draw like this shape, which is not correct. So you need to, now you know how to draw the corners, I already teach you, Okay, so now let's take a look at this question, So same, minus 2 means I'm going to do, my amplitude is still positive 2, is a flip graph. Okay, this time round, the coefficient of x is half. So 2 pi divided by half is 4 pi. The shift is 2, So you see, I draw my new middle line, which is y equals to 2. Amplitude is 2, so 2 plus 2, so is 4. 2 minus 2 is 0. So I have my max, my minimum ready. And my new middle line. Then, because one cycle is 4 pi, so 4 pi divided by 2, 2 pi divided by 2 is pi. So one small interval is pi. So 2 pi plus pi, 3 pi. So now I have my 4 parts. Now draw the 4 critical points. But take note, this is supposed to be a flip graph. So it is not starting from maximum. It starts from the minimum. So minimum, 0, maximum, 0, and minimum. Then you draw the shape. Same thing, the corners, you also visualize like you're drawing the continuation. Drawing continuation. It's just that you draw half of it. Understand? So this is how you draw the flip cosine graph with a new middle line, y equals to 2. So next one. Same. This time round, my shift is -1. Amplitude is 2 because it's positive 2 in front of cosine. My period is 2 pi. So my new middle line is at the y equals to -1. -1 plus 2, 1. -1 minus 2, -3. Because I want to draw one period only for 2 pi. So 2 pi, pi over 2, and 3 pi over 2. The amplitude is the thickness of your graph. You see this? Amplitude 1. This is amplitude 3. Okay? So once you have the 4 intervals ready, draw the 5 critical point. This is a normal cosine graph. So you start from the max, 0. The 0 is at the new 0. It's no longer at the x-axis because we have a shift -1. 0, minimum, 0, maximum, 5 critical point, then you draw the shape. So the two corners, you just visualize that your continuation, but of course it's invisible continuation. Why did the third graph start at 0? Or because it is a flip graph. You see that in front of the cosine is minus 2. So the minus here, don't give me the amplitude is negative 2. Amplitude is always positive number. The minus tell me that I have to flip. So usually what I do is I just put a bracket here. Flip is to remind myself that when I draw my graph, it is a flip graph. So this is not a usual cosine graph. This is a flip cosine graph. That's why it started from the minimum. The usual cosine graph start from maximum. The flip cosine graph start from the minimum, which in this case is 0. Period is I take 2 pi divided by the coefficient in front of the x. So 2 pi divided by half is 4. 2 divided by half like is 4. So just put 4 pi. What thing need to minus 2? So we need to minus 2. Yeah, the middle line is 2. So minus 2, you get 0. That's your minimum. So if it wasn't flipped, it will start at 4. Let me see. Yes, correct. If it wasn't flipped, let's say for example, let's say this is not negative 2. This is just like that. So yes, it starts from 4. That means this way, this way, this way, and then after that, this way and this way. The other direction. No, sine and cosine is not opposite. Is it opposite? No, it's not. It's 90-degree phase difference. You see, if I cover this, isn't it cosine graph? Like that. Correct or not? So it's a phase shift. So cosine and sine actually is a phase shift of 90-degree. Okay, but in secondary school, O level, we no need to bother about a phase shift trigograph. Okay, we don't learn that. It's not within our syllabus. No, not talking about principle today. Okay, I'm talking about trigograph. I still have a last question to do. So now we are done with cosine graph. Okay, we are done with cosine graph. Okay, let's move on to tangent graph. Where's my tangent graph? Could I see the sine graph for a while? Wait. Now, this is the sine graph. This is the cosine graph. Okay, screenshot if you need to, because I'm not going to upload this. I don't know what is your trigon. Sine graph always start at the shift. Yes, because it starts from the middle line, 0. Yes, it starts from the shift. I never studied mathematics at any university. I studied engineering. Okay, so now let's take a look at tangent graph. Tangent graph. So I draw the original tangent x first. So take note that when we draw tangent graph, the period is slightly different from the sine and cosine graph. So my amplitude same is the number in front of the tangent. So in this case, the amplitude is 1. For period, the difference is for sine and cosine, the numerator is 360 divided by the number. But for tangent graph, it's 180 degree divided by the number. So 180 degree divided by 1 because the coefficient of x is 1. So my one period is 180. In this case, again, there's no plus minus. So the shift is 0. Okay, stay here. You see, put here. Star. O level do not test shift for tangent graph. So they will not ask you to say, okay, tangent x plus 1 minus 2 or whatsoever. No. For tangent graph in O level, they will only test you with different amplitude and different period. That's all, full stop. Okay, so don't come ask me how to draw 2 tangent 2x plus 1 minus 1. I'm not going to do that. Okay. Okay, so now let's take a look over here. So how are we going to draw the tangent graph? tangent period is always 180. No. I would say if it is 1x, yes, the period is 180. But if, let's say in this case, you see this is 2x, right? 180 divided by 2, my period is 90. What? So, Cookie, I cannot say yes to your question. Okay, so, see here. Okay, so see here. Okay, so okay, let's continue. So I know that my tangent graph one period is 180, so we will draw 180. This is one cycle. So the so-called good thing about tangent graph is the one cycle is only 2 interval. Our sine and cosine, remember one cycle we need to have 4 interval. So tangent graph only 2 interval. So now 180, I only need to cut half 90 degree. And then at the 90 degree, you need to draw this line called asymptote, which is this dotted line. So what is this asymptote? Just asymptote is just like a line that they hate it. You cannot touch it. So in other words, the asymptote is a line, it's a guideline. It's a line whereby your graph, when you draw, it cannot touch the asymptote. It cannot touch the asymptote. Cannot touch. So one cycle is 180, so you just do 90, draw the asymptote, dot, 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 dot. Okay, so then after that, you draw from 0, curve up. So when you draw it towards there, you go very near to the asymptote, but it does not touch the asymptote. You cannot cross over to the asymptote, you cannot touch the asymptote. So it must be a line very near to the asymptote, but doesn't touch, doesn't cross. Then after that, this side, it will be from the asymptote, you go up to the 0. So this is one cycle. Okay, for tangent, how do you show the amplitude? Okay, just now I got see a question asking that. How do you show the amplitude? The amplitude is always, you see, my one cycle, then after 90 degree, right? So you need to do another half. That means 90 divided by 2, which is 45. Then at the 45, you go to dot, 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 up, dot, 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 over 1. This is 1 is because my amplitude is 1. So in other words, if my amplitude is 2, for example, 2 tangent x, my amplitude is 2. So everything is the same except that this last part, this one will be 2 instead of 1. So to show the amplitude is just by this part. Understand? Okay, so I'm done with one cycle. But because I want to draw up to 360, so I pick another one. So we already know one interval is 90. So 180 plus 90, 270. 270 plus 90, 360. So again, another cycle. So at the 270, you got to draw your asymptote. Do the same thing. From the 0 to go up. Close to the asymptote, but do not touch. This side also same thing. So close to the asymptote, but do not touch. So we are done with the second cycle. So tangent graph period is 180 divided by the number. So remember just now our sine and cosine, we always take 360 divide. So tangent is a little bit special. Tangent is 180 divide. Okay, so now I'm going to increase the difficulty a little bit. So now I change my amplitude. This is the amplitude 2. This one my period also change. So amplitude 2. Period is 180 degree divided by 2, so it's 90 degree. So always draw one period, one cycle at a time. So assuming that this graph, this question asks to draw up to 180 degree. So I draw one cycle, which is 90 degree. See, 90 degree. Half of it is 45, so I draw the asymptote at 45. I don't do discrete mathematics. Okay, so asymptote is 45. So you do the same thing, draw the shape. The shape is exactly the same. Then remember, I teach you how to draw the amplitude. After the first asymptote, half of it, which is in this case 22.5, just dot, 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 up, dot, 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 over. Because my amplitude is 2, so you just put a 2 here. That's all. And you duplicate it to the other side. And this is how you draw y equals to 2 tangent 2x. Yes, iceberg. I do the same thing over here. So yes, tangent graph, although they don't test for shift up, shift down, but they test for flip. So in this case, you can see that my number in front of the tangent is -2, right? So remember I say amplitude is still +2. Just put a bracket there, is flip. Okay, my period in this case, you see, I do this in terms of radian. That's why I take pi divided by the number, so my period is pi. So you see how I draw? Pi over 2. So my asymptote is at pi over 2. This time round, because it is a flip graph, so it didn't start from 0 upwards. It starts from 0 downwards. So now you compare. So now let's take a look. You compare this and this. Okay, let's compare like that first. Do you see that it's flip? Okay, flip. Flip. Okay. Then in this case, the amplitude is 2, right? So, but because my graph is no longer upstairs, so in this case, same, you half here, then you put here -2. For sine and cosine, one complete cycle is also 180 with 5 points per cycle. Wrong. For sine and cosine, one cycle is 360 if it's x. See here? Period is 360. When it's x, 360. So 360 degree and then 5 points per cycle. It's not 180. Sine and cosine is 360 degree with 5 points per cycle, provided it is x. So if your statement will be correct only if I have 2x, then my period is 180, then your statement will be correct. Okay, so we are done with tangent graph. So please next take a screenshot if you need to. I'm going to go through the last question. I'm going to go through the last question very fast, because 7 o'clock already. Can I screenshot the tangent graph? Yes, here it is. So you can screenshot. Go ahead. Can't we just put the -2 anywhere? No, cannot. You must put it at the first half of the first asymptote. Sine and cosine graph is commonly tested. Tangent graph seldom test, but it is still within syllabus. So it depends whether you're lucky or not lucky but you must know how to draw tangent graph. Okay, asymptote is always half of the period. My period is 180, right? So half of it 90. So that's the first asymptote. Okay, let's move on. Okay, so for fast, okay, I'm going to show this one. This is question number 5. Okay, let's move on. So now this question asks to draw sine x -2. So now by now you should be expert to find out what's the tree information. Okay, this question automatically always write out the amplitude, period, and shift. Full stop. This one, amplitude, number in front of the sine 1. Coefficient of the x is 1. So my period is 360 divided by 1. So how do I know whether is it 360 divided by 1 or is it 2 pi divided by 1? Because later part of the question, they give me degree. So I know I want to do it in terms of degree. So I have this information already. Okay, so next. The -3 cosine 2x. You see? -3. My amplitude. Please remember my amplitude, write the positive value. So amplitude is 3. If you put -3, they will mark you wrong. Remember, because I see a few of my students during their EOY or their WA3, they put -3, which is wrong. So amplitude is 3. Then just put a bracket flip to remind yourself that it's a flip graph. So the period is 360 divided by 2. So my period is 180. In this case, there's no shift. So my shift is 0. So some students say, hey, shift still need to do not, since no shift still need to put this shift, meh? Make it a habit to find this APS, right? So you know that there's no shift, okay? Just make it a habit. So let's move on to the next part. Okay, the next one is they ask you to solve the equation y1 equals to y2. So because already 7 o'clock, because I'm going out for dinner, so I just refer to the solution that I did previously, then I just explain the question, okay? So if I talk a little bit too fast, pardon me a little bit, refer to the TikTok replay and watch my explanation again. So over here, so my y1 is sine x minus 2, my y2 is minus 3 cosine 2x. So I'm just going to equal them together and solve this equation. Okay, so what I do is I shift everything to the left-hand side. So 3 cosine 2x plus sine x minus 2 equals to 0. So you are supposed to solve this equation. I can't change my sine x, I can't change my minus 2. The only thing I can change is my cosine 2x. So I'm going to make use of my double formula. So double formula is over here, right? So formula sheet give us these 3 choice for cosine 2a. So which one to pick is, you got to depends again what's your neighbor. My neighbor is sine. Of course, I'm going to make use of cosine 2a change to the sine. Your y1, y2 is in front, what? y1 is this. y2 is this, So we place the cosine 2x with this. But of course, this one is a formula sheet. You know, you must know how to put it back. Put it as x. Okay, so now this 3, then bracket, you need to rainbow the 3. So it becomes 3 minus 6 sine square x plus sine x minus 2 equals to 0. So when you have this is just like a quadratic equation. It's just that quadratic equation in terms of algebra, you solve x. This one, you solve sine x. So it's actually just like quadratic equation. So I ended up having 6 sine square x minus sine x minus 1 equals to 0. Okay, so factorize this. I get 2 sine x minus 1, 3 sine x plus 1 equals to 0. So I have sine x equals to half, or sine x equals to negative 1/3. So we need to solve. Solve means you need to find your x. So this is what I do. So sine x equals to half. I have to solve my x. So sine x is positive, is in the first and second quadrant. Find the basic angle. So sine inverse half is 30 degrees. So my x will be first quadrant, basic 30. Second quadrant is 180 minus basic. And that's why I get 150. So for the sine x equals to half, I got 2 answers for my x, which is 30 and 150. Why leh? But I still haven't talked about behind. Very fast. Talk fast. Quick. Let's complete this. Okay? Okay, then now here, sine x equals to minus 1/3. So sine negative, third and fourth quadrant. Find the basic angle. Yes. Okay. So my basic angle, sine inverse 1/3. This is my basic angle. Because I want my x is in the third and fourth quadrant. So in the third quadrant is 180 plus basic. Fourth quadrant is 360 minus basic. So this is my 2 values. So in the end, I got 4 answers. Always put it in the ascending order. So this is my 4 possible answer for the x. Okay, so this is how you solve trigo equation. Can always go to my YouTube channel. Okay, search for trigonometry. I believe you can see tons of video there. Okay, so this is how you do this part. Okay, next. Okay, I took the whole page already because no space. My part C sketch on the same diagram. Now we are going to draw the 2 graphs. So, ta-da! ignore my top part. I draw this one, I forget to flip. Ignore this one. So this is how you draw the graph. So now is they ask you to draw on the same diagram, correct? So just now we already have all the information, amplitude and shift, right? So you see how I draw this one, So you can please refer to the TikTok replay and see how I draw. You can attempt, always draw one at a time. So you can draw the cosine graph first, and then after you draw the sine graph. How I draw the sine graph and cosine graph? So-called rewind back and refer back to how just now I recap on how to draw the sine and cosine graph. Can you go back a bit? I have a question. Which part? Yes. Sure, how you know when to use SATC? Because you see, sine x equals to half. My x can have two answers. Because sine positive is in the first and second quadrant, A and S. Right? So with this, I will know that I need my two answers. One is the basic, one is 180 minus basic. The Talirika, you say you have a question to ask me, you ask me to go back, then you never ask me the question. No, the integer question I already went through already. So if you want, I mean, as in, I don't know whether you are referring to the just now the first question. Refer to the YouTube replay when it's uploaded on Tuesday. Yeah, the Talirika never asked question, so I'm going to move on. Okay, so now after we plot the graph, so this is how you draw the graph. Okay, so now next, this part D. Okay, a lot of students don't know what they want from this one. Go to where you start with sine, Okay, here. Wow, Nikki, Fire, we ending already lah. Yes, tangent 2a has formula also, from the formula sheet. But today I'm going to cover on cosine 2a. Talirika, can you please faster or not? You want to ask what about this portion? One, two, 3, 4, 5. I'm moving on. I'm not coming back to this question already. No, because it's in the third quadrant. Third quadrant is 180 plus basic. Okay? It's like you want to come to here, 180 plus basic for the third quadrant. For the fourth quadrant, it is 360 minus basic. Okay? Okay, now let's move on. Okay, so now the last one. So this y2 minus y1 more than 0. Actually, what you need to do is do one more step. I just need to shift my minus y1 over to the other side. So in other words, they're asking you, what is the set of values of x for y2 above y1? y2 above y1. So now you look at your graph. Where is your y1? y1 is this sine graph. Sorry, y2 is the cosine graph. So they are asking you where is the cosine graph above the sine graph. So now look at this. This part, this is a cosine graph. This one is a sine graph. Okay? Let me just use the highlighter. You see this and this and this part, Okay, the portion that I highlight, they are saying they want the y2 above the y1, which is the yellow color above the orange color. Okay, so in this interval, the yellow is above the orange. Okay, so this side is orange above the yellow, which is I don't want. So if I continue, okay, maybe I should continue this part so that you can see. So I highlight the yellow color as the cosine. The orange is the sine graph. So when we talk about this part, they want the yellow above the orange. Understand? You see, if I cover this part, do you see that the orange is above the yellow, which I don't want? This part, the yellow is above the orange, I want. This part, orange above yellow, I don't want. This part, yellow above orange, I want. This small part, orange above yellow, I don't want. Okay, how do I get all this value is, remember just now when we solve the equation, we get these 4 values. So when we solve equation is the intersection point. And that's the 2 graph. So this is the intersection point, this is the intersection point, this is the intersection point, this is the intersection point. 1, 2, 3, 4. And that 4 points is this, and this. And that is why we know that I want between 30 to 150, between 199.5 and 340.5. So how do I know whether I need to put the equal or not? The less than, do I need to put equal? Because in this question, this one more than don't have equal. If this one got equal, then you just put equal. This one don't have, so this one also don't have. Was waveline amplitude. Okay, so we are done with the AMath O level revision paper 1 part 1.